Right, hello everyone. So, we're going to do hopefully another patent review, or a review of a padlock that has a specific patent against it. Now, most of you will probably know that I'm a fan of lever locks. That's my main interest, hence the still disassembled Squire Defiant over there. But I came across a cheap Squire 39. And it's a fascinating lock because it actually has two patents hidden within it. One for the lock itself and a much older one for the core. So we can discuss hopefully two patents and the workings of them in one lock. So I found this one on eBay. This was about £5 plus postage. And when I got it, I thought, oh, that's actually quite nice. It's in really good nick. It works well. It's got a good click to it, good clunk to it. It's got 3 keys. All the protection around it is in really good condition. There's hardly any rust on it. I thought, I can't take that apart. So I was lucky. I looked on eBay again, and I found its brother. Its brother's had a much harder life. So let's put this one over here. His brother has had a really hard life. Let me turn the light on here. Get some light on this guy. Okay. All of the outside plastic is bashed at the top and the bottom and on the sides. It only has 1 key. Came with 2, but as you can probably tell, the bitting on those 2 is very, very different. Put them next to each other, hold them up. There we are. Very, very different. And actually the bitting on the key that works is almost, which is this one, is almost non-existent. That's darn close to a blank key in my book. So, I don't have any problems with taking this one apart. Okay, I'm sure we've all had days like this. So I've recorded this once, got back to the house, downloaded it, tried to patch it together and realised that I turned the recording on when I was meant to turn it off and off when I was meant to turn it on. So I'm missing half of the stuff that I was trying to record, and you have about 3/4 of an hour of me swearing at a padlock. So let's try this again. I've taken it apart. I've ground out the pins, the rivets I suppose they are. As you can see in the rivet, they're bent, and they bend because as you grind the end off and give them a little bit of a tap, all the laminations move, and they just move enough to be able to put a kink into those, so they weren't coming out straight with force. I had to take the thing apart lamination by lamination and tap it on through, but it's all back together again, currently just held together by 2 long M3 bolts. It still works, so perfectly good padlock, apart from the fact you can take it apart with a screwdriver. So what we're going to do now is I'll undo these bolts and I'll take it apart very slowly. If anybody's ever thinking of taking apart one of these laminated locks, 2 things I've learnt is, apart from the pins bending quite considerably, one is that don't try and do it while the thing's locked, because the spring pressure in here will just explode it all into bits. And secondly, remember which order the laminations came apart in, because it is important which way they go back again. So I'll pause this for a second, undo the laminations, and we'll start at the bottom for a reason that will become apparent. Right, back again. I've taken the bolts out, so the only thing holding this together is my finger pressure and a bit of gravity and some balancing. So I think I said at the beginning of this video, although it's been a while since I did that, this padlock has 2 patents. So I'm going to take the bottom off. It's just the plate here that holds everything else in place. It allows the key to access the cylinder, the mechanism, and it holds the spring in place. Now you'll note I'm going to put them down in the right order so I remember how they happen. So nice spring there that forces onto the shackle so it pops open, and what we have now is, hopefully, because it won't come out when I ask it to, there we are, the cylinder. Now this cylinder has its own patent. It is patent number 658 693. I'll put some pictures up, but I've got my copy here for reference. It's from 1949, officially published in 51. So it's quite an old patent in that respect, or at least in relation to the lock. And the patent is all around the manufacturability of the cylinder, specifically the outer cylinder casing. Now historically what would have happened was you would have the casing, the outer casing, and you would drill a blind hole for each of the cylinder, each of the pins, and you would drill it in from this side. So you would drill down from here and you would leave a blind hole at this end. So you would drill in, stop, 2 or 3 mil short of the end, and that's where the spring would go. You'd then load the cylinder with all the pins, and you pin it up in the same way that all of us, if you do repinning, pin. So you put a follower in, you'd put the first spring in, set of pins in, you'd move the follower forwards, and you'd rinse and repeat. Now that's obviously quite time consuming, especially in a production line. It also has the negative aspect of having some holes, perfectly pin sized, on the bottom of the cylinder housing, which meant that if you rotated the mechanism through 180 degrees, there was half a chance that one of your pins would end up getting stuck and you'd end up with a lock that was totally and utterly useless. So the patent for this is all around assembly simplicity, fundamentally. So what happened was that they've drilled in through the top here. They've drilled their pinholes from the top down into the centre, which would obviously be empty. They would then assemble the whole unit, and they would assemble the pins from the top. So you'd have your key pin go in first, then your next pin, then your spring. You'd do the same thing, and then you push down a little brass cap and you'd crimp it over the top. And that holds the spring force in place. So you don't have a row of holes at the bottom, and your assembly is quite simple. So that's the first patent I wanted to discuss. Quite a nice invention. Simple, effective, and fundamentally save time and energy in the assembly process. So that's that. Let's have another look at this laminated lock. Fundamentally, the bottom half of it is all the same. There's some slight variations in the lamination cuts, but they are fundamentally there to do two things. One is to house the cylinder, and the other one is to house the spring. So that's the bottom half. Nothing hugely exciting about that, just a nice stack of laminations. Now comes the top half. Now, this is where my disappointment came when I took this padlock apart. I then had a look at the other one that I've got, and I was slightly disappointed with that one as well. I then went online and had a quick look, and I found a video by Lock Noob on the same padlock, and again I was disappointed. Why am I disappointed? Well, I'm disappointed because this padlock has quite clearly stamped on it that it is a strong lock. Patent 2103706. Well, I have here a copy of 2103706. It says so in the corner. And if you look at this patent, it is very specific about what it's about. And it's about a ball bearing locking mechanism. So the idea being you have your cylinder, you have a separate rotating cylinder at the top here with cutouts in it and two ball bearings. You would then close your shackle and you would rotate the cylinder around it, would force the ball bearings out. We all know how ball bearing, but this was, I'm assuming, the first ball bearing design. So why am I disappointed? Well, I'm disappointed fundamentally because when I took this apart, and I'll take these apart, just take the top two off there, you can quite clearly see in there that is not a ball bearing. It is not a roller. It is not a cylinder in the centre with two cutouts in it. What it is a sprung-loaded bolt. Which begs the question, why did they stick the patent number on the lock? And it's on this lock, and it's on that lock, and they're both sprung loaded lock mechanisms, bolts. So that's my main disappointment, because I was hoping to have quite an interesting discussion about a roller stroke ball bearing lock mechanism, which I now can't do. So the one other thing that I think, or the two other things that I think are vaguely interesting in this design, which are similar across the piece, I would expect. Again, those laminations at the top, all very similar, fundamentally designed to take the sliding bolt mechanism in there. You then have one lamination here, which if I take it off, you'll be able to see, only allows the cylinder to rotate by 45 degrees. It doesn't actually matter which way you turn it, because it naturally sits this way, and then it can only rotate to there or to there. And so that's allowing the, or stopping the key from going any further. And so that's just an interesting one. And the second one is just a bit of manufacturing interest on the way the shackle's held in place. There's not a separate unit to hold the shackle in place. There's one of the laminations, and what they've done is they've got a section here, I'll bring it up a bit closer, which has these two little arms on it. Those, I would assume, when the lamination is originally punched, those arms would be further down, and then you would put the shackle in place, and the shackle has a thinned section just here. And you would put it through, and then probably some bloke with a screwdriver or something similar would just bend those up into place, and that's what retains it. So that's really quite a short run through of the Squire number 39 laminated padlock, which isn't anything to do with patent number 2103706. So when is a patented padlock not a patented padlock? Well, when it's a number 39 Squire. I hope that was interesting. I'm going to put this all back together again, and it'll go on my wall as a interesting demonstration piece. Thanks a lot.